To another video. It's your favorite math professor here, Dr. Tarcia Hubert, and in this video we're going to be talking about how to construct a binomial probability distribution. If you watched the last video, you saw that a binomial probability distribution was a discrete probability distribution that has only two outcomes. Okay, so here's the definition again. It's a discrete probability distribution that describes probabilities for experiments in which there are two mutually exclusive outcomes. So that's just a refresher on what a binomial probability distribution is. And what we're going to look at is how in the world do you calculate the probability of those outcomes, those possible outcomes. All right. So there is a formula for the binomial probability distribution. And it says the probability of obtaining X successes in N independent trials of a binomial experiment is given by, here is that formula. P of X is equal to N choose X, P to the X times 1 minus P to the N minus X. So recall that N is the number of trials and P is the probability of success here, and 1 minus P is the probability of failure. All right. Our X is going to represent the number of successes that we are interested in obtaining. All right. Now there is one new formula here that we have not seen yet, and it is this combination formula, this N choose X. All right, that's called the combination formula, and what it is equal to is it's equal to N factorial, which we haven't talked about that either, over X factorial times N minus X factorial. Now factorial means you take a number and you multiply it by every integer less than it. So for example, 5 factorial is equal to 5 times 4 times 3, times 3 times 2 times 1. And so that would be 5 times 4, which is 20, 20 times 3, which is 60, 60 times 2, which is 120, 120 times 1 is 120. So 5 factorial is equal to 120, all right? So 5 factorial. So that is some new formulas that we have not seen yet within this statistics course, but what we're going to do, or what I'm going to allow you to do, is to use a combination calculator to calculate the combination, all right, in this formula. So we're going to go to Google. We're going to go to Google, if I can get there. My computer tripping. Okay, we're going to go to Google, and I'm going to show you how to get to a combination calculator. All right, so I'm in Google, and I'm going to just Google combination calculator. And there's one called combinations calculator soup. You can use that one, but there are many that are available. And basically, it uses N and R instead of N and X. And you just type in the values for N and R, and it will calculate it for you. So this is what I'm going to use at calculator soup in this video. So I'm going to come back to it in a moment once we get to our example. All right, so I'm back at the formula for the binomial probability distribution. So if I want to find the probability of an outcome, I have to do N choose X times the probability of success raised to the X power times 1 minus P, which is the probability of failure raised to the N minus X power, okay? So let's look at an example. According to the American Red Cross, 7% of people in the United States have blood type O negative. A simple random sample of size 4 is obtained, and the number of people X with blood type O negative is recorded. Construct a probability distribution for the random variable X, okay? So we want to construct a probability distribution, which means we want to list all of our possible outcomes of the 4 people selected, of how many could possibly be blood type O negative, all right? So if we think about it, our possible outcomes is, if we select 4 people, it could be the case where none of them are blood type O negative, so that would be 0. Or it could be where 1 of them is blood type O negative, or it could be where 2 of them is, or 3, or 4 of them is, all right? So there are actually 5 different outcomes. So the outcome, this is a binomial experiment because the outcome of them, what we're measuring is that they're blood type O negative or not. So there are 2 outcomes, but for our random variable X, there are 5 outcomes, okay? So we select 4 people, and we want to know how many of them is blood type O negative. So what we want to do now is we want to calculate the probability of each of these possible outcomes. This is the fact that none of them would be blood O negative, blood type O negative. This is what 1 of them would be, 2 of them would be, 3 of them would be, or 4 of them would be. So we're going to start by calculating the probability for 0. So we want to calculate the probability of x equal to 0. And so remember, the formula was n choose x. So our n here is 4 because there were 4 people that are randomly chosen. Our x is 0. Our probability of success, so is this 7% right here. If they are blood type O negative, there's a 7% chance that that will happen. So our p would be 0.07. And then that would be raised to the x power. In this case, our x is 0. And then we would do 1 minus 0.07. And that would be raised to the n minus x, which is 4 minus 0. So we would do 4 choose 0. 0.7 raised to the 0. Anything raised to 0 is 1. And then 1 minus 0.07 is 0.93. So 0.93 raised to the 4th power, okay? So now if we do 4 choose 0, we actually will get 1 as the answer, okay? And I'm going to show you in a minute how I got that. But right now I'm just going to write it. So that'll be 1 times 1 times 0.93 to the 4th power. And this is a multiplication symbol. Multiplication symbol, this one is actually a decimal. So I'll end up with 0.93 to the 4th power, which is equal to, if you raise that to the 4th power, you get 0.748 and some more numbers. I'm just going to round it to 3 decimal places. So right here, we get 0.748. All right, so that would be our probability for x equal to 0. So that's the probability that none of the people selected would be blood type O negative, 0.748. All right, now I'm going to go back to Google really quick and show you how I got this value for 4 choose 0, okay? All right, I'm back in Google in my combinations calculator, and I wanted to do 4 choose 0. So I'm just going to hit 4 in this first one and 0 in the second one and hit calculate. And you see the answer is 1. And look, it will walk you through the process of plugging 4 and 0 into that combinations formula and how you actually get 1 as your answer, okay? So that's how I got 1 for 4 choose 0. So you can come back and use this to calculate your combination for each one of those that we are about to calculate. All right, so now I want to calculate the probability of x equal to 1. And so in my formula, I will have 4 choose 1. And the probability p, which is 0.07, raised to the x power, which in this case, x is 1, times the probability of failure, which we already said was 0.93, because that was the 1 minus 0.07. And that would be 4 minus 1. So when I plug in 4 choose 1 into my combinations calculator, I actually get 4. So this is 4. 0.07 to the first power is 0.07. And this will be 0.93 to the third power. So you want to plug all that in your calculator. I would start with the exponent. So do 0.93 to the third power, then multiply that by 0.07, and then multiply that by 4. And you end up getting 0.225 if you round it to 3 decimal places. So I get 0.225 here. All right, so that will be the calculation for 1. Now I want to calculate the probability of x equal to 2. And I just went and typed in those values in the chart so that it'll be more neat than me writing on the screen for this one. So for x equal to 2, that's going to be 4 choose 2 times 0.07 to the second power times 0.93 to the 4 minus 2 power. So hopefully you're kind of starting to see the pattern in the formula. This is 4 choose 2. If you plug that into your combination calculator, you end up getting you end up getting, sorry, my screen zoomed in, you end up getting 6. And then you have 0.07 to the second power. And then you also have 0.93 that ends up being 0.93 to the second power. That's a 9. If you multiply that all out, depending on what kind of calculator you have, you can enter it in straight, or you could do it piece by piece, do the 0.07 to the second and the 0.93 to the second, multiply those together, and then multiply by 6, you end up getting 0.025. I don't know why my screen keeps zooming in, but 0.025 is what you end up getting for the probability of x equal to 2. All right, now we want to repeat this process for the probability of x equal to 3. You end up getting 4 choose 3 times 0.07 to the third power times 0.93 to the 4 minus 3, which is going to be to the first power. 4 choose 3. If you plug that in your calculator, you end up getting 4. So you get 4 times 0.07 to the third power times 0.93. If you put all of that in your calculator, 0.07 to the third, multiplied by 4, multiplied by 0.93, you get 0.001 if you round it to 3 decimal places. So 0.001 is what you get for x equal to 3. Okay, and we want to calculate one last one, the probability of x equal to 4. That's going to be equal to 4 choose 4. Oh, it's supposed to be a 4. 4 choose 4 times 0.07 to the fourth power times 0.93. Remember, that's your 1 minus 0.07 raised to the 4 minus 4 power, which is to the 0 power. So you get 4 choose 4. When you plug that in the calculator, that's 1 times 0.07 to the fourth power times 0.93 to the 0 power. Anything to the 0 power is 1, so you end up with 0.07 to the fourth power. And when you plug that in your calculator, you end up getting 0.000, and I think one more 0 in the 2, but since we're rounding to 3 decimal places, that means the probability of getting 4 is oops, that was supposed to be a 4. That's supposed to be 0.000. All right, we want to answer a few questions about this probability distribution. And the first is the probability that 2 people selected will have blood type O negative. So that's just 2 in our chart. So what is that probability? It will be 0.025. All right, that one is pretty simple. Nothing special you need to do there. All right, for the next one, what is the probability that fewer than 2 people selected will have blood type O negative? So in this case, we want to know what is the probability of 0 or 1. Because fewer than 2 would include the 0 or the 1 here. So you will take those two values, because OR probability means you would add those two values together, 0.748 plus 0.225, and that actually comes out to 0.973. That's 0.973, and that's how you would do that one. For the next one, what is the probability that at least one person selected will have blood type O? So at least one means 1 or more. So that's the probability of 1 or 2 or 3 or 4. So since OR probabilities, you add them, then you'll take all these probabilities right here and add them together. 0.225 plus 0.025. Plus 0.001 plus 0.000. Sorry, this is coming out kind of sloppy, but y'all get the gist. I'm adding all 4 of these right here, and you get a total of 0.251. All right, so you get 0.251 for that one. All right, so this is how you would construct a binomial probability distribution, and how you would answer some questions in regards to that binomial probability distribution. If you have any questions whatsoever, don't hesitate to put them in the comments or send me a personal email. I hope you understood everything. Thank you for watching, and I will see you in the next video where we talk about how to calculate the mean and the standard deviation of the binomial probability distribution.